Parallel lines with transversal some more. But this time I'm going to look at some examples. So again, I've got this situation talked about in the last video. M and N, and they're parallel. Right? Little marks tell me that they're parallel. And I got a transversal. Okay. So first thing I know is that all these angles, the little angles, are congruent. So this one, right, and this one, the big angles are also congruent. And that the big and little pairs add up to 180. Right? Measures add up to 180. So, example. Okay, simplest case is something like this. They tell you, okay, you've got your parallel up that M and N are parallel. So they're given M is parallel to N. And you're given, say, that this angle is 40 degrees. All right? And they say, okay, what are the other angles? They're going to ask you, what? Maybe they'll ask you for all of them. Maybe they'll ask you for some specific one. Doesn't matter. It's easy. Once you got one, you've got them all. Right. First thing. Well, this is a small angle, right? Small angle. So all the other small angles are congruent to the same. They have the same measure. So this is 40. This is 40. This is 40. And then also this is 40. And also this is 40. Now, we can do this a couple ways, right? These two angles at the top are supplementary. We know they're supplementary because that's part of the theorem that we learned, but also just because, look, this makes 180 degrees right here. So you don't have to remember something new. You just have to know, okay, well, that makes 180 degrees. This is 40, then this must be 180 minus 40, or 140. Right? Okay, now these two add up to 180. But again, if this is 140, that's my big angle, well, then all the other big angles have to be congruent to it. So this is 100, and this is 140, and this is 140, and this is 100. So I got them all. Now I know all the angles. So it doesn't matter what they ask me. They may ask me about this angle, they may ask me about this one, whatever. It doesn't matter. You fill out the whole thing, you know the measures of every angle. All right, so that's an easy case. That gets a little trickier when they throw in some variable expressions. It doesn't really get much trickier. It adds a little extra step. Don't get yourself confused. So suppose we've got 15 here. This is 15, and let's see, what do I got here? This is 11x minus 2. So I'm going to look at those angles, and I can fill out the whole thing, and maybe I will for starters, just so you see. Well, this is 15. Is that my big angle or my small angle? Look at it, get a picture. Okay, that's the small one. This is small. If this is 15, then this is 15 too. It's another small one. This is another small one. So this is 15. Okay? This is 15, and so on. I can fill out the rest. I'm not going to bother right now because all they're asking me is to say find x here. Well, I know that 15 is the measure of this angle. I also know it's 11x minus 2, so I can just say, oh, okay, well then I can write my equation 11. 11x minus 2 equals 15, and then I can just solve that equation from there. To both sides, 11x equals 17, and x is going to be 17 divided by 11, which is some weird number, but I don't really care, because I got my answer. We got a calculator if I really want to. But 11 divided by 17, or 17 divided by 11, 17 11. All right, so that's one kind of problem you'll see. But all you got to do then is just figure out how to measure each of your angles until you can set up an equation with one angle equal to another. Let's look at another example. So, suppose I've got x plus 139, and I've got over here 132. Same deal, right? Okay, well I know one, right? I know 132. And is that big or small? Well, look at it. Size it up. Yeah, it's a big one. So all the other big ones have to be 132 also. 132. Oh, this one's 132. And this one's 132. Hey, this is all I need. I can go ahead and figure out, okay, well, this would be 180 minus 130 would be 48. Is that right? That's right. You check that. 148. Or needs to be 48. But I don't care really about these anymore. All I really want to do is find x. I got my equation now, x plus 139, because I know that this angle is x plus 139. I also know it's 132. It tells me that x plus 139 has to equal 132, right? Okay, so what do I do now? Subtract the 139 from both sides, and I get negative 7. Now you might say, oh wait, but it's a negative number. I can't have a negative number because it's a measure of an angle, and angles can't have negative degrees. Yeah, that's true. You can't have negative degrees, but nothing here has a negative degree. It's just the x is negative. And negative 7 plus 139 is still a positive number, 132. Okay, let's look at one more example. I'm going to do one more. I'll do one for you. So in each of these cases, remember, these are all problems where we're given that m is parallel to n. So what have I got? Negative 1 plus 14x and 12x plus 17. Alright, so, big or small? Okay, this is a small one. So this is negative 1 plus 14x. Every other small angle is negative 1 plus 14x. It's true in this case I don't have a number. I don't have a degree measure for any of these. I've just got two variable expressions. It's okay, that doesn't matter. This is negative 1 plus 14x, and this is also negative 1 plus 14x. It's the same measure. This is, well then this is another small angle, so it's also negative 1 plus 14x. Oh, and this is a small angle too. So this is also negative 1 plus 14x. Okay, so I've got negative 1 plus 14x equals 12x plus 17, right? Because this angle is equal, it's given to me that this is 12x plus 17. Using my m is parallel to n, I can figure out that it also has to be equal to negative 1 plus 14x. Now I've got an equation. Negative 1 plus 14x equals 12x plus 17. All right, what do I want to do? Maybe I'll subtract 12x from both sides. Get different ways to do this. Play with the point to get 2x over here. And negative 1 plus 2x. Get 17 over here. And I can add 1 to both sides. 2x equals 18. And then I can divide by 2. And I get x equals 9. And that's my answer. I can check it. I can plug in 9, right? Negative 1 plus 14 times 9. What is 14 times 9? Right, I won't do this here. You guys check it. You check it, because I won't waste time checking this. Okay, the same thing. We knew our small angles are congruent. Our big angles are congruent. So we just wrote, oh, this is the same measure. This is the same measure. And this is the same measure. And that one gave us our equation. I'm going to give you one other problem. You to do it, pause the video. After I write it down, pause the video, do it on your own, and then check again. Check back and see if you got the right answer. So here's the problem. 23x minus 5 and 21x plus 5. Okay, so you've got those two measures. For you to try to figure it out. Pause the video, and come back and done. Okay, so now you pause the video. What do I have? This is a big angle, right? This is my big angle. Well, that means that all the other big angles are the same measure. So they're all, whatever this is, 23x minus 5. So this big angle is 23x minus 5. And this big angle, oh, that's also 23x minus 5. Now I've got an equation, because I know it's 21x plus 5. I also know it's 23x minus 5. One I was given, the other I figured out using the fact that m and n are parallel. All right, so I'm going to set up I got my equation here. Right. All right. Okay, I'll subtract 3x from both sides. Actually, no. I subtract 25x from both sides. We got 5 here. We got 23 minus 21 is 2x minus 5. Obviously, it doesn't matter what you subtract first or anything. I just do it in a way that I have a positive coefficient for x. Add 5 to both sides. All right, I got 10. 10. It's 2x divided by 2. And I get x equals 5. That's my answer. X equals 5. All right, if that's what you got, then congratulations. If it isn't, then check. Maybe I got the wrong answer. Never know. Okay?